Hello, welcome to my channel. I am Rosario Borgesi and I am a software engineer. And today I will show you how to test, compile, and deploy a smart contract to the Ethereum blockchain. I hope you will enjoy the video, and if you do, please click the like button and subscribe to my channel so you can stay updated. So let's get started. Before delving into the code part, we need to perform the operation reported in this slide. First of all, we need to install the MetaMask extension for Google Chrome at this URL. Always from MetaMask, we need to create an Ethereum account and we need to be careful to save the 12 words which will be shown to us because we cannot get it back later on. And these 12 words will be needed for our code to be executed. So this is the MetaMask page, as you can see, and this is the MetaMask extension that you will install. And in the end, you will get something like this. So this is our account. This is our the address of our account. This will be explained later on. In the third step, we need to add the Sivolia test network to our MetaMask account, and to do so, we will make use of Chainlist at this URL. So, this is the Chainlist web page. We have searched our Sivolia test network by pasting this chain ID in the search networks tab, and we just need to add this network to our MetaMask account. So in the end, when we will open up our account, we will find the Sivolia network among the other networks that we have in our account. Then we need to add some Ethereum, some ethers, I'm sorry, to our Ethereum address, and to do so, we will make use of a faucet at this URL. So this is the web page of our faucet. To get the ethers, we need to essentially copy the Ethereum address and paste it here. We check this box and then we start the mining. What basically does this mining is that it will make use of our CPU work to mine some blocks, and we get some ethers, Sipolia ethers, in reward. But be careful that these are not real ethers, because we are talking about fake ethers, because Sipolia is a test network. But in order to get our rewards, we should overtake this claim threshold. So once we get our Sipolia Ethereum, we can stop the mining, and the ethers will be sent to our Ethereum address. And if sorry and if everything went correctly, we should find our ethers here. Then we need to register to the Infura webpage and get the API key. Basically, Infura is a service which exposes this API, which allows us to interact with a lot of Ethereum networks. We need to interact to the Sipolia test network, so we need the API key for the Sepolia test network. And this is the Infura web page. As we said before, you need to create an account and get this API key for the to allow our application to interact with the Sepolia test network. Okay, we arrived to the last step. So we obviously need to clone our repository, and we can go at this URL where you will find the repository I have created for this video. And now we will clone the repository and we will start to look at the code. We are at the GitHub page of the repository, and we just need to copy this URL here. Then I created a folder which I called test Ethereum, and then we can start a terminal here at this folder, and we basically have to clone the repository. So git clone, and I will paste the address I have copied before. So here we have cloned our repository. So we get inside it with cd okay. Now, of course, if I execute git branch, I will see only the main branch, but we need to use the branch called simple contract. So we execute git checkout simple contract. Okay. So now we should have all this code in our repository. So now what we need to do? I opened up my IDE, which is Visual Studio Code, but obviously you can use whatever IDE you prefer. And here we can simply drag and drop this folder here. So it will open the project. And now we will take a look at all these files that we have here. So first of all, we have the contracts repository, which has just this file inbox.sol, which is nothing but our contract. So this is the last version at this day of Solidity. So it is a simple contract. Basically, it has one variable, a constructor, and a set message. As you know, Solidity also auto creates a get message for this variable, so we don't need to create it explicitly. So this is our contract, but of course you can create any contract that you want because this is just a template at the end of the day. So then we have this folder files here where we have a file called seed.csv. Here you have to paste the 12 words that we have said earlier to save, because these are needed to open up our Ethereum account, because without our 12 words we cannot get the application, cannot make the library, cannot make use of our Ethereum account. But be careful not to use the 12 words of an account where you have some real eaters, because if you lose your 12 words and someone gets your 12 words, your seed phrase, they can steal your money. So be careful with this. Then we have our test file. I forgot to tell this, of course, the project is in TypeScript, as you can see. And we have, this is our test class, basically, to test our code. And basically, it makes use of Ganache, which is a library which creates an in-browser network, which is used to test our contract locally. And this is obviously different from the Sepolia network where we will deploy our contract. Then it makes use of the Web3 library. The Web3 library is our portal to the blockchain. So it allows us to interact with the blockchain. So this is an important library. And obviously what it does here basically is that you will see some error. We will fix them in a while, so don't worry about this. We will cover this. And basically it gets a list of accounts and deploy the contract to this Ganache test network. So basically what this test does, it asserts that that we have an address from our contract, so it has been deployed essentially. Then it tests that as you can see here, you have a constructor, so we set an initial message. Here we are verifying that this initial message is correct. Then we try to change this initial message to another message to make sure that the set message function is working properly. So this basically tests the fundamental part of our contract. Then we have our compile file, which basically is just compiling the contract. So as you can see here, you have Solk, which is the compiler for Solidity, and we call solk.compile, which will compile our contract. Then we have the file deploy.ts, which is used to deploy the file to the Sepolia test network. As you can see, this is a library HD wallet provider, which is used to gives us which will give us a provider in order to connect to Sepolia. Then we will make use of the Web3 library. These are two libraries that I will explain later on. And also this is the simple utility library. And we will make use also of the .env library to be able to get an environment variable, which we will need. So basically, we get the compiled contract from the compile.ts. We will read the seed from the CSV file, this one that we have discussed before. We get the API key. This is the API key the Infura API key, which allows us to connect to the Sepolia test network. Basically, we will make here some basic checks. You know, here this is the utils.ts file. We just check that the input is not null, is not undefined, and that is not empty, basically. And we do the same for the seed to make sure that these variables have some sound value. Then we call this constructor to create the HD, the provider. We create another constructor to create the Web3 instance. And then here we will deploy the contract. Essentially, we get the list of our MetaMask accounts. Then we will deploy our contract. Okay. And no, basically the send method is what actually sends the contract to the network, and of course this is an asynchronous function, so we should wait until it finishes, and then we print a message of to certify that the operation has finished well. And this is important in order to because if we don't write this line, the application will hang up, and so we need this to stop this provider engine. And this is basically the deploy function. So as we said before, this is another the seed file basically reads the CSV file that we have discussed before, the seed.csv, and basically does this. Essentially, it reads the file, and essentially it reduces it in a single string with this separator, with this blank space as a separator. So it does not do anything exceptional. Then this is needed because with TypeScript this was needed in order to be able to use the Solc library. And then, as we have seen before, we have the utils file. The other file that is important is this the .m file, where we have our API key, which is what the API key that we have got before from Infura. If we open the README file, we will see that in the section Project Setup, there are a series of steps that we need to perform in order to run our application. So we have already cloned the repository to our local machine, so we need to run npm install to install the dependencies. So if we open our shell here, so we are correctly in the simple contract branch, we can execute npm install, and this will download all the repository that we have listed in our package.json file. So this is pretty fast. So in this repository, node modus have been created, all have been downloaded, all the repository needed for our application. So now there are a series of modification that I have done to the file um, of the type .t.ts, basically the declaration file for JavaScript that um, allow us to use in TypeScript the JavaScript libraries, because some of these files without this modification there are some compilation error. So as we can see if we go for example here we have a compilation error. So what we need to do, the first modification, as we see in the readme file, we need to open up this file here. So we must go to node modules here, web3 ETH contract. So then we open up libs, types, and then contract.ts, which this one, and at line 6, sorry, at line 251, which is here, we need to replace this with unknown, with this array of unknown. This is the first modification. The second one, at line 6, we need to replace. So we need to go here and replace this one with this piece of code, and then we need to modify the second file, which is web3 here, lib types, and then web3.t.ts, and need to add this string here, because otherwise it gives us compilation error. So at line 22, so at line 22, which means here we add this piece of code. Honestly, I don't know if this is the best solution, but without it, the code don't compile. I opened an issue already, but probably I need to open at this day other issues. So this way the code compiles. So I know this is maybe this is not the best solution, but this is the best solution I found. So I'm open to improvements if someone has one. So in the meantime, I have replaced the seed.csv file with my 12 um, words seed phrase, and replaced the API key property with my API key from my account, from my Infure account. So now I run npm run test in order to run the test. And as we can see, the test has have been passed. So here he gives some information about the transaction, the contract created, the gas used, and so we have the tests were passed. So now if we want to deploy the contract to the Ethereum blockchain, we can run npm run deploy. This is my account. Now takes a little time because this is an important difference with the test. In the test, the network, the deployment to the Ganache network is really fast because the block time is really slow. But here that we need to deploy to the Sipolia test network, the block time is, if I remember correctly, 15 seconds. So at least 15 seconds, 15 to 30 seconds are needed in order to deploy. So this is the um, address of our deployed contract. So we can copy it. And now we want to verify that our contract was deployed correctly to the network. So we go to this website, which is Etherscan Sevolia. We go here and we search for our contract, which is this one. We search and we find that this transaction, so our contract has been deployed correctly. We can also check our the account the code of our account, which is starts with 0x1f0, 0x1f0, and ends with FE28. So FE28. So this certifies that our contract has been successfully deployed. Here, of course, we can see um, the the details of our transaction. As you can see, there is a gas fee which has been paid. So every time we run a transaction, uh, we pay the fee. So we have reached the end of the video, and I hope it has been useful and that you have learned a lot. But if you had any issue on, or if you want to ask me anything, please comment below, and I will reply as soon as I can. And thank you for watching, and I hope to see you in the next video. So bye.